Okay, here are the solutions to Week 8 assignment, Lessons 4 and 5 in Unit 4. The first one here, a bacteria population is tripling every hour. By what factor does the population change in 1/2 hour? So if it's tripling every hour, the function would be whatever the beginning balance or beginning population is. So times 3 to the x, right? And so then this is every hour. So we're going to take that 3 and raise it to the 1/2 power, and that's your new factor that you would multiply the beginning population by. So 3 to the 1/2 is here, and we know that 3 to the 1/2 is also equal to the square root of 3. For number 2, a medication has a half-life of 4 hours after it enters the bloodstream. A nurse administers a dose of 225 milligrams to a patient at noon. They want us to write an expression to represent the amount of medication in milligrams in the patient's body at 1 p.m. on the same day. So we're going to start out by writing our function. So we start with 225 milligrams, and the half-life is when we have 1/2 left. And so that's our multiplier. And it takes 4 hours to do that, so we're going to put x over 4. So after 4 hours, if x is equal to 4, we'll have 1/2 to the 1 power, and that will give me a half of 225. So at 1 p.m. on the same day, we would be multiplying by 1/2 to the 1/4 power. So we'll put a 1 up here, and that would be the expression then for after 1/2 hours. And then the next one, they want to know 7 p.m. on the same day. So then we would take 225. Our multiplier would still be 1/2 since we're talking about half-life. And then 7 p.m. would be the 7/4 to the 7/4 power, or 1 3/4. Letter B there, the expression 2.25 times 1 to the 5/2 represents the amount of medicine in the body sometime after it's administered. So what is that time? So if we change 5/2 to fourths, that's 10/4, and so that would be 10 hours after, or 10 p.m. since it's administered at noon. Number 3, the number of employees in a company has been growing exponentially by 10% each year. So by what factor does the number of employees change each month? So it would be 1.1 each year then, and a month would be 1/12 of the year. So we would have 1.1 to the 1/12 power. For letter B, every 3 months would be 1.1 to the 3/12, or the 1/4 power. And letter C, every 20 months we would have 1.10 to the 20 over 12, which would reduce to 5 over 4 then. 5 over 3. So this would be 20 12ths, 3 12ths, and 1/12 of a year. Number 4, the value of a stock decreases exponentially since its purchase. The 2 points on the graph show the truck's initial value and its value a decade afterward. So we want to express the car's value in dollars as a function of D, time D in decades since the purchase. So we'll call it V of D, and it starts out at $40,000, and we need to figure out that multiplier, and then D is going to be decades up here. So in 1 decade, it went from $40,000 down to $24,000. So that's a decrease And we need to figure out what multiplier it was there. So we would take 24,000 and divide by 40,000. And when you do that, you will get 0.6. So the multiplier here is, I'm sorry, it's not 1.6, it's 0.6. So after a decade, it lost, or the percent decrease was 40%. So for letter B, write an expression to represent the car's value 4 years after the purchase. So if it's 4 years after the purchase, it would be 40,000 times 0.6. And then this would be 4/10 or 0.4, or however you want to write that, 2/5. And then by what factor is the value of the car changing each year? So each year, it's going down by 0.6 to the 1/10 power, since there are 10 years in a decade. And so if you multiply that out, you get about 9.95. So it's losing about 5% of its value each year. It's worth about 95% of its value each year. Number 5, the value of a stock increases by 8% each year. Explain why the stock value does not increase by 80% each decade. So for number 5, there are 10 years in a decade, and so you're multiplying by 1.08 each year, and so that would be to the 10th power. So 1.08 is not to the 10th, is not equal to 80%. So letter B then, does the value increase by more or less than 80% each decade? So we would take 1.08 and raise that to the 10th power, and you can see that you get 2.15, 2.16, which is about 216%, so more than 80% each decade. Number 6, decide if each statement is true or false. So this is from lesson 3. 50 to the 1/2 is 25. That's wrong. 50 divided by 2 is 25. The square root of 30 is a solution to y squared is equal to 30. That's correct. When we take the square root of both sides, the positive square root is one solution. 243 to the 1/3 is equivalent to the cubed root of 243. That's also correct. And this is nonsense here. 20, the square root of 20 is not the same as, would not be a solution to m to the 4th is equal to 20. Number 7. Number 7, it should not have shown up on your PDF. I'm going to have to figure that out, but this is from a lesson we didn't do, so I'm not going to go into that now. So we can skip that. And then on to lesson 5. So the table shows the monthly revenue here of a business rising exponentially since it opened an online store. So when it opened, they had $72,000 in revenue. 1 month later, we don't know, but 3 months later, they had $90,000. And 6 months later, they had $112,000. So from here to here, and from here to here, that's 3 months. Each jump here that we know of is 3 months. And so we want to know, how is it growing? So from 72 to 90,000, if you go over to Desmos and divide 90 by 72, we get 1.25. So it's the revenue grows by a factor of 1.25. Every 3 months. That's what we know so far. So when we want to write this equation for the revenue in terms of months, we would start with 72,000 and then multiply by 1.25 to the m divided by 3, because then after 3 months it would be 1.25. And then we want to find the monthly revenue 1 month after its online store opened. So now if we take 72,000 times 1.25 to the 1/3, that would be R of 1. We can figure out, if we go back over here, we can take 72,000 times 1.25 to the 1/3 power, and we get 77,559.65. So let me take a look at that again. 77,559.65. So it would be worth 77,559.65 then. And then letter D, explain how we can use the value of R of 1 to find R of 4. Well, since this is a 3-month period from 1 to 4, that would have the same multiplier there. So we could just take the R of 1, 77,559.65, and multiply that by 1.25 to get R of 4. So I don't know if they've asked you to do that, or we could just look at we could change this into a table here. I'd have to have an x to the 1/3 up here, or x over 3. Let's just try it once. If we turn that into a table here, so here is our, what was the one, our 4? So here it is, 96,994 or 49.56. So that's another way of finding the revenue in the 4th month. Number 2, at 7 a.m., a colony of 100 bacteria is placed on a petri dish where the population will triple every 6 hours. So we want to select all that are true about the bacteria population. So when the bacteria population reaches 900, 12 hours have passed since the colony was placed on the petri dish. So we know that it's, let's see, it'll triple every 6 hours. And so, yeah, that's true, because at 6 hours it'll be 300, and then another 6 hours it'll triple again, so that will be 900, from 300 to 900. Letter B says 3 hours after the colony is placed on the petri dish, there are 200 bacteria. So that would be 100, so 3 hours, 100, let's see, times 3 to the 1/2. I don't believe that's going to work for us, so that would be an X. Let's put this in our Desmos also. So we start out with 100, and it's tripling every 6 hours. So we can write this as 3 to the 1, x divided by 6. And there's our function then. And then if we turn it into a table, and get rid of these negative hours and just look at what's happening. Whoops. So there's 6 hours later, it's tripled. And then if we keep going, there's 12 hours, there's 900. So it tripled again. So every 6 hours it's tripling. And so what was the question here? Let's see. So 3 hours after the colony is placed in the petri dish, there are 200 bacteria. No, it's more like 173. So, and you could put that 3 in for the x, and you would multiply 100 times 3 to the 1/2 power. So that's why B doesn't work. But C does work. It's about 173 after 3 hours. Letter D, in the first hour the colony is placed on the petri dish. The population grows by a factor of 3 to the 1/6. Yep, that works. We just put a 1 in for x, and we get 3 to the 1/6 if it's tripling every 6 hours. And then letter E, between 8 and 9, the population grows by a factor of 3 to the 2/3. So that's a 1 hour period, so it would be 3 to the 1/6. So that's not true. Number 3, the graph represents the cost of a medical treatment in dollars as a function of time, D, in decades since 1978. And we want to find the cost of the treatment in dollars when D is equal to 1. So if D is equal to 1, that's another half decade time. So we can just use this factor that it grew in half a decade and multiply it again to find the cost, or the cost of treatment after 1 decade. So let me show you what I mean. Let's see. So from 0 to half a decade later, we can find that it grew by 150, or 202 divided by 150. So let's take a look at that. Oops. So it's 202.50 divided by 150, and that's 1.35. So it grew by 35% in that half decade. So it looks like it's going to grow by that again. So we could just take the 202.50 and multiply by 1.35, since that's another half decade. And so I want to multiply by 1.35, and so I get about 273.4. So I would take 202, this is 1.35, and then since that was a half decade, so to go from here to here, that's the same amount of time, so I can apply that same factor, 1.35, and I get 273.4. Number 4, the exponential function is given by 3 to the x. By what factor does f increase when the exponent x increases by 1? So it looks like it increases by 3 then. So 3 to the first is just 3. By what factor does f increase when the exponent x increases by 2? Well, then it's going to increase by 9, because 3 squared is 9. And the letter C, by what factor does f increase when the exponent x increases by a half? Then we're talking 3 to the 1/2 power, or the square root of 3. Okay. A piece of paper has area 93.5 square inches. How many times does it need to be folded in half before the area is less than 1 square inch? So it's going to start out at 93.5, and we're going to fold it in half each time. And so we want to know how many folds, that's X, it's going to take before it's less than 1 square inch. So 93.5 times 0.5 raised to the X. And we could find a table here and just keep increasing our X's by 1 here. Whoops. So after 4 folds, 5 folds, we want it less than an inch. So there, after 7 folds, the area will be less than the square inch. So this would be 7 folds. Number 6, the area covered by an invasive tropical plant triples every year. By what factor does the area covered by the plant increase every month? So if it triples every year, your multiplier is 3, but then we have to remember that there's 12 months in a year, so it would be 3 to the 1/12th power, or the 12th root of 3. That would be your factor every month then. And that's it. So I hope this helped. Thank you.